Okay, so it says Sally deposits $10,000 into an account that pays 4.7% interest compounded a year. Every single year it's going up by this percent, okay? What is the balance after 5 years? So this is exponential growth. Okay, this is the interest, the rate that it's going up every single year, and this is the starting amount. How would I write this as an equation? What do you think, Emma?
Y equals 10,000 parentheses 0.47.
Oh, sorry, I put 1,000. Sorry. Okay, parentheses what?
0.47 plus 1.
What did we forget?
You're missing a zero, miss.
I'm missing a zero. What else is missing?
1 plus.
1 plus.
4.7. That's what I said.
No.
No, 1.047.
Okay, very good. Because remember, you have to write it as a decimal. So you have to move the decimal over 2 times to the left. Okay? You have to write. Do you remember?
Why 2?
What do you mean?
Why is it not just 0.47?
Because what's 0.47 as a percent?
47.
That's 47%. You got it? So you got to move it twice. Okay. All right. So now raise this to the x power. This is the equation. Please make sure you write the equation first, because if they ask for the equation, that's what they want as the answer choice. Now we're going to answer the question. The question is, what is the balance after 5 years? Okay, so what's the total after 5 years? Where are we going to substitute the 5? For the x, because x is x years. Okay, x is always like time, hours, months, years, days, whatever. So we're going to write this as 10,000, and we got 1.47 thousandths, and we're going to raise it to the 5th power. We're going to see how much money this is. So let's type this in. We have 10,000. Make sure I type in the right amount of zeros. And then we got times. And then this is caret key, 5 years. How much money did y'all come up with here?
12,581.
Very good. This is $12,581 and how much cent?
53.
About 53 cents. I'm gonna put the squiggly lines for about. Raise your hand if you got this right. Okay, good. All right, so now, anyone still writing? Okay, I'm gonna pause here. I want you to try the decay problem, please. Okay, I need you to try the decay one. Okay, group, I'm going to set the timer again. Get as far as you can get in 5 minutes. And then at that time, I'm going to go over and see what you got. Okay? All right, let's do it. With decay. Y'all did a good job. Okay, so let's see what we have. Spokesperson from table 1. All right. A, what does 28,000 represent?
It represents the starting amount.
Very good. This represents the starting amount or the y-intercept. So this is the initial value or the starting amount. Perfect. Raise your hand, spokespeople, if your table, everybody got that right at your table. Okay, perfect. All right, so now we're doing decay. Shh. Listen, please listen to this part, because this is one of the most missed but easiest questions when it comes to exponential functions. A lot of people miss this question, okay, because they mistake the rate of decay for the common ratio. The common ratio is not the rate of decay. Remember, B is the common ratio. This is B. But remember, B for decay is equal to 1 minus R, okay? It's not R itself. It's not 86% decrease. That's not the way it goes. It's 1 minus R. So you have to figure out, because remember what I told you when we did the example for the sweater? In order to figure out the amount that you pay, you have to include the 100%. And that's what all of these include. They include the 100%. Okay? But you want to figure out what was just the rate by itself without the 100%. Okay? So, in order to figure out what is the rate, what is the R, you're going to take whatever B is and plug it in here. B on this side was 1 plus R. B for decay is 1 minus R. Thumbs up. I'm good with what you said. Sideways, I'm confused. I need everybody to vote, please. Okay? All right, cool beans. Okay, so now we're going to replace. We're going to put here. And now we're going to solve for R. How do you solve for R here? How do you get R by itself, Blau? So we subtract 1 from both sides. So when you type this in, notice I put 1 here. You know why? Because of the decimal. Okay. So when I subtract, that's going to give me a negative what? Very good. Okay. 14 hundredths. And this is negative R. Completely get R by itself. We already know it's a negative percent. It's because it's decreasing, right? But still, to get R by itself, you divide both sides by a -1. And that's still going to give you R is equal to this. So what is the percent here? This is 14% decrease. Okay? Any questions about that? Brayden, you all right? Because she was giving me that look. You sure you're okay? Yeah, okay. It's gonna take a minute, right? It's sinking in. Okay, let it marinate. All right, so I'm gonna give you 5 more minutes, and I need you to complete. Some of you are already finished with 5, but I need you to complete 6 as well. Okay. All right. Let's do it. Okay, let's look at number 5. Shh. Please make sure you have this right, and then we're gonna paste this in our notebook. Okay. So we got the student population at the local high school is 1,375. And it's decreasing, okay? It's decreasing by a percent. Since it's decreasing by a percent, this is an exponential decay function. Anytime it increases or decreases by a percent or a common ratio, it is an exponential function. This is exponential decay because it's decreasing by a percent each year. Okay. What will the student population be after 7 years? Let's write the equation first. How do you write the equation for this? Dennis, how do you write the equation for this problem?
It will be
Y
is equal to AX, right?
Okay. So y is equal to, since it's exponential decay, it's this, okay? Don't forget this. So the A is going to be the starting amount. What is the starting amount?
400.
4? No.
That's for the other problem.
Yeah, that's for the other problem. That's okay, baby. 1,375. Okay, that's the student starting population. Do you understand? Then we have times. We got, remember, the 100%, right? Minus, what's the percent that is decreasing? So how do you write 2% as a decimal? 0.02. Just move it 2 times over, right? Okay. I mean, this way. Sorry. All right. So raised to the x power. Or they can say t. That's the equation. Does that make sense? Now we want to solve the equation. Okay. How do we solve the equation, Renee? You calling on the right one. You calling on the right one. Because he'll do it. Won't he will? Yes, he will. Come on. Jaden, what do you think?
I think you're supposed to time.
Okay, so this is subtraction here, okay? In order to solve the problem, we have to substitute 7. 7 years either for y or for x. Which one of those variables do we plug in the 7 for? The x, because x represents the time. Y is the total amount. X is the time. All right, so we got y, the total amount is equal to 1,375. We're going to do the, when we subtract this, what does this give us? Decimal what? 98. This is 98 hundredths. Now we're going to raise that to the 7th power. Okay, so now let's type this in. Student population. I need some batteries. 1,375. My apologies. Then we got times 98 hundredths, caret key 7. And look, now what can we say about this student population? What is the student population going to be here? 1,194. Why are we going to put 1,194 and not put the decimal? Because you cannot have a part of a person. Okay, so it's going to be about 1,194 people. Okay, any questions? All right, looking at the last one. An endangered species only has 400 left in the wild. So that's all that's left. If the species is decreasing by 6 5/10% each year, how many animals are left after 4 years? Okay, y'all ready? How would I write this? I want you to try again, Dennis. How would I write this as an equation?
It will be y equals
Mm-hmm.
400.
Mm-hmm.
It will be parentheses.
Mm-hmm. Very good.
1
Mm-hmm.
minus
Mm-hmm.
r.
What's the R in this case, baby?
6.5%.
How do we convert 6 and 5%? Remember, we have to write it as a decimal.
Yeah.
How do we write that as a decimal? Jacob, are you writing this down? How are we going to write this as a decimal?
0.65.
Okay, so we got a decimal. 6.65 is 65%.
Oh, 0.65.
Okay. All right. And then we're raising this to the x power. That's the equation, or t, okay, because it's time. Doesn't matter what letter you use there. Okay, so now how do we solve this? Jacob? How do we solve this? How do we figure out what it's going to be after 4 years? Somebody want to help him? Silas, can you please? What are you going to do that? Very good. So you're going to put 4 here. When I subtract that, what do I get in the parentheses here? I get a decimal what? Okay. And I raise this to what power now? 4. Very good. Okay, so we're talking about animals. You cannot have part of an animal. So how many animals is this? Because we can't have part of it, huh? 300 what? 306. Or what's the decimal afterward? I forgot. Okay, so 306. All right, any questions? Please paste this in your notebook. This is page 4. Exponential word problems foldable. Please make sure you paste that in your notebook. Okay, listen. On this sheet right here, there's 2 different things that I need for you to do, okay? Besides answer the question. Shh. Please listen to the directions so you don't get lost, okay? All right, so remember, if you're finding the rate, the growth rate, okay, the formula you use is B is equal to 1 plus R. You substitute the B and you solve for R. What about if you're finding decay rate? What's the formula used for that? B, somebody said. Any questions about that? Is there anyone that's lost? All right, before you finish this sheet, turn over on the back. I need you to do this with your group. Okay? You ready? Okay, in your group, I want you to come up with a word problem. Shh. You need to come up with an exponential word problem. Let me be more precise. Shh. With your group, I need you to come up with an exponential word problem. I need you to solve it. I need you to write the equation and solve it. Please also make sure that you create a table. Shh. With your table, all you need is 3 ordered pairs. I need 3 ordered pairs. Please stop doing that. Okay, and this goes on the back. Questions? All right, I'm done. That's what I need from you, please, 4th grade.